Welcome to the Deep Dive, where we cut through the noise and get straight to the knowledge. Today, we're diving into a topic that's not just eating software, as NVIDIA's CEO Jensen Huang famously put it.
Yeah.
It's really reshaping our world. Artificial intelligence, we're seeing breakthroughs, well, almost daily, it feels like, pushing boundaries faster than maybe many of us anticipated. From your perspective, what's one development lately that's really, pushed things in an unexpected way?
It really is an electrifying time. And for me, it's the sheer speed at which these AI models are becoming multimodal and showing, pretty advanced reasoning. We're seeing models go from just, text generation to understanding and interacting across text, images, audio pretty seamlessly.
Right.
But what's also fascinating, maybe concerning, is how this power is consolidating. Control seems to be gathering in the hands of just a few big tech companies, and that immediately raises questions, doesn't it? About influence, transparency, potential biases. It feels a bit like an enclosure of the internet commons, where these crucial resources, data, compute power, they're becoming increasingly centralized.
That's a powerful analogy, enclosure of the internet commons. What's the sort of profound insight there for innovation's future? Does this centralization risk maybe stifling smaller developers? Or even narrowing the perspectives inside the AI itself, if only a few are deciding things?
Oh, absolutely it does. The insight, I think, is that innovation thrives on openness, on diverse perspectives. When you gatekeep these foundational resources, it creates a choke point. It limits who can build, what ideas get explored, and ultimately whose values get encoded into these really powerful systems. This isn't just about money, it's about the future shape of AI and how it serves humanity.
And that's precisely our mission today, isn't it? We're exploring how decentralized AI, DAI, using blockchain technology, could offer a counterbalance, a crucial one maybe. We'll be focusing on that foundational infrastructure layer that makes DAI possible. And we're going to take a deep dive into one project that's pioneering decentralized compute. Think of it like this. Bitcoin aimed to decentralize finance, right?
Right.
Well, crypto tech might now be paving the way to democratize AI itself.
It's definitely a parallel revolution unfolding, and it's trying to tackle these exact challenges head on.
You mentioned AI eating software. What does that profound shift actually look like, say, on the ground? For businesses, developers, how's it reshaping things right now?
Well, it means pretty much every major organization across almost every sector is scrambling. They're scrambling to integrate AI, to secure the huge amounts of compute power needed, the vast data sets to fuel it all. This intense competition, it's not just for cool new features, it's driving fundamental changes. Changes in how products are built, services delivered, decisions made, LLMs, the large language models, they're becoming almost the new OS for many apps.
And it really does feel like a small club, doesn't it? Just a handful of companies dominating.
That's certainly the perception, yeah, and it's largely accurate. The modern AI scene is, undeniably led by a few players: OpenAI, Google, Anthropic, Meta, Microsoft, you know the names. These giants have poured billions into getting the compute power, the massive data sets needed for these advanced models. And the progress since, say, ChatGPT's launch in late 2022, it's been incredible. Models went from just text to multimodal handling text, audio, images, like Google Bard evolving into Gemini, OpenAI's GPT 3.5 moving to GPT 4.0 and beyond, showing much better reasoning, better understanding.
Okay, so this concentration, it raises big concerns. We mentioned influence, bias, but what's a less talked about, maybe, but still critical concern when so much AI power rests with just a few?
That's a good question. One less discussed, but I think critical concern is about resilience and diversity in AI development itself. If most of the cutting edge stuff, research, deployment happens inside just a few big organizations, that creates a kind of single point of failure for the whole ecosystem, doesn't it?
Oh, yeah, I see that.
What if one company's internal biases or even just a strategic choice they make inadvertently limits where AI development goes? This narrow funneling of resources, of talent, it could homogenize AI's future. We could lose out on those unexpected discoveries, those diverse applications that often come from a more open, decentralized environment. Kind of mirrors history, where public resources got consolidated for private profit. Now it's happening with digital resources, compute, data storage.
That's a really compelling point about resilience and diversity. So if that's the centralized picture, what does DAI actually propose as a viable alternative path?
Well, decentralized AI offers, I think, a compelling alternative. Blockchain tech brings some really powerful principles to the table. Things like transparency, immutability, clear ownership, and a system built on, well, robust, almost adversarial testing. These qualities could be exactly what AI systems need to tackle those centralization worries. As Matthew Siegel over at VanEck put it, there's a significant chance that AI applications will be crypto's raison d'etre.
That's a bold statement. So how would you define DAI in practice? What does it actually look like?
Okay, at its core, DAI imagines a system using multiple AI models, but they're controlled and trained by different parties. All working together, though, to produce valuable outputs. That's a stark contrast to centralized AI, which relies on one model, or maybe multiple models, but all from one organization.
Right.
The benefits seem pretty clear. You could seamlessly combine specialized models. You could have models competing for the best outputs, which could drive down costs, spur innovation. It's really about opening up the playing field.
It's easy to get caught up in the flashy AI agents we see touted on crypto Twitter, the app layer stuff. But you're saying the real foundation for DAI lies much deeper than that, right?
Precisely. Those agents are often just the tip of the iceberg, the app layer, and frequently they're still relying on centralized LLMs underneath it all. Below that, you've got a middleware layer, frameworks, verification protocols, things like that. But our focus today, it's on the crucial infrastructure layer. That's what provides the fundamental building blocks for truly decentralized AI.
Professor Wendy Wong from UBC has this very clear framework. She says AI has three fundamental bits: data, compute, and algorithms.
Right.
Can you walk us through how those three combine to make AI and why breaking them down like this is so important for DAI?
Yeah, Professor Wong's framework is excellent, super helpful. Data, that's the raw material, right? The info AI models learn from. Compute is the processing power, the muscle needed to train and run the models. And algorithms, those are the blueprints, the instructions, the logic defining how the AI learns and operates. Those three inputs give us AI as the output. Simple, but profound. And for DAI, it's crucial because decentralizing each of those components is how you really democratize AI's foundation. What's fascinating is that even before ChatGPT really exploded onto the scene in 2022, DeepIn projects, decentralized physical infrastructure, they were already building decentralized infrastructure for these exact components.
That foresight is pretty impressive. You mentioned projects like Filecoin, Arweave, BitInsert, tackling data and algorithms, crucial pillars, obviously, alongside compute. Before we dive deep into compute, can you give us a quick insight? What specific challenges are these projects solving that, say, centralized cloud storage or algorithm marketplaces just can't? And why is that vital for DAI?
Sure. So for data, think about centralized cloud storage. It can have single points of failure, right? It can be subject to censorship. And often there's a lack of transparency about who accesses your data, who owns it. Projects like Filecoin tackle this. They incentivize a global network of people to provide storage. And it's verifiable through clever crypto proofs like proof of space-time, proof of replication.
Okay.
This ensures data integrity availability without a central boss. Imagine AI training data sets that just can't be deleted or messed with. Then you have Arweave. Their thing is permanent data storage. You pay once upfront and the data is, theoretically, there forever.
Forever.
Yeah. It makes historical data sets, train models into a kind of public, immutable good that fosters truly open AI development, prevents data lock-in.
So it's about making data tough, resilient, and always accessible. Sounds absolutely fundamental for long-term AI work. What about algorithms?
Well, with algorithms, centralized marketplaces or proprietary models often create a black box, right? You don't really know how they're trained, what biases might be lurking inside, how they get their answers. BitInsert is a great example of a decentralized approach here. It's a whole network designed to incentivize both the development and the distribution of AI models. And human expertise too. It uses this unique proof of intelligence consensus and its TAO tokenomics. It creates this competitive marketplace where different AI models constantly contribute to a kind of collective intelligence. The best ones earn rewards.
Right.
This drives continuous improvement, ensures a diverse range of algorithms are available, and importantly, verifiable.
So instead of one company deciding the best algorithm, there's like this constant open competition of intelligence. That's a powerful concept. And this brings us neatly to compute, which is where that global race to acquire compute power is really, really heating up.
Yeah.
Big tech pouring billions into cloud infrastructure. And this is precisely why a decentralized solution for compute is so interesting. Which leads us right into our deep dive on the Render network.
Exactly. Compute is the engine, right? For training, for running AI. Historically, we've just rented power from big centralized companies, Amazon, Google, Microsoft. But now, projects like Render are trying to turn compute power into something publicly accessible, a distributed commodity.
And the render network uses that fantastic analogy. It's like Airbnb for GPUs. Can you unpack that for us quickly? How does that work?
Yeah, it's a great visual, isn't it? Render network basically connects people with idle GPU power, those are the node operators, with people who desperately need that power. People doing demanding tasks like AI training, high-end 3D rendering, those are the creators.
Yeah.
So essentially, if you've got a powerful graphics card just sitting there, not doing much, you can potentially rent it out on the network.
Okay, so what makes decentralized compute via render so much better than the traditional options? What are those common frustrations it's trying to solve?
Well, traditional centralized GPU services, they have some pretty significant drawbacks that Render aims to fix. First, cost. It can be really expensive, especially for long, heavy jobs like training an AI model.
All right, I've heard that.
Second, scalability. It's often limited, sometimes slow. You might end up waiting in line for the powerful GPUs you need. Third, access isn't really equal, is it? Big companies often reserve huge blocks of resources, leaving smaller teams or individuals kind of struggling. And finally, there's vendor lock-in. Once you build your whole workflow around one provider, it's hard to switch.
So a decentralized network like Render really flips that script. Who benefits most from these advantages? What does it unlock for them?
It absolutely does flip the script. Render offers some clear advantages, significantly lower costs, potentially, because it taps in to GPUs that already exist but are just sitting idle worldwide. Scaling is flexible, potentially instant, need more power. The network can theoretically pull in more nodes on demand. This levels the playing field. It gives potentially equal access to anyone, regardless of their budget or, corporate backing. And for the GPU owners, it's a way to earn while they sleep, essentially, turning a depreciating asset into an income stream. It unlocks access for individual artists, indie game devs, small AI startups, people who might otherwise be completely priced out.
That makes a ton of sense. So how does Render Network actually do all this? What's the engine under the hood?
Yeah.
Especially with its token.
Okay, so the basics. Creators submit their jobs, often in this specific format called ORBX, usually via software like Octane Render or compatible plugins. Node operators connect their GPUs to the network, ready to work. And the RNDR token, that's the fuel. It powers the whole ecosystem. Creators pay for rendering or compute time in RNDR. Node operators earn RNDR for providing their GPU power. All these transactions happen transparently on the blockchain. There's a small transaction fee, usually about 0.5% to 5%. That helps support network's development.
Okay, but how do we know the work gets done right? Especially for critical stuff like AI training or complex rendering. How is payment handled fairly?
That's where proof of render comes in. It's their unique consensus mechanism. Basically, it verifies that the tasks are completed correctly before any payment is released. It ensures only validated work, meaning the output matches the job specs and quality actually gets rewarded. This builds trust and transparency. Creators know they get what they paid for, and operators know they'll get paid fairly for legitimate work.
Got it. Now, Render started mainly with high-end graphics, but it's expanded. What are some of its diverse uses now, especially in AI?
Yeah, its core applications are still strong in demanding 3D rendering. Think movie VFX, game assets, metaverse environments, architectural visualizations. It also supports NFT creation, digital art, complex simulations, virtual production, lots of graphics-heavy stuff. But here's where it gets really interesting for AI. Render Network is increasingly used for AI compute tasks, things like NeRF and light field rendering, and also generative AI tasks.
NeRF and light field rendering.
Yeah.
Those sound pretty advanced. Can you give us a quick, digestible explanation? What do they do and why do they need so much compute?
Sure. NeRF stands for neural radiance fields. It's this really cool technique using neural networks to create super realistic 3D scenes just from a few 2D images. Imagine snapping a few photos of, say, a statue and then being able to generate a totally new view of it from any angle looking incredibly real.
Wow.
And light field rendering captures basically all the light rays bouncing around in a scene. This lets you create these incredibly immersive virtual experiences where you can actually change your viewpoint after it's rendered. It's like stepping into a frozen moment and looking around.
That sounds computationally intense.
Hugely intense. Both generate hyper-realistic digital content, but they need massive amounts of power to process all that complex light and spatial data. That makes decentralized GPU networks like Render a really good fit.
So creating incredibly rich, realistic digital worlds from limited inputs. Sounds perfect for AI's generative side. What about some real-world examples, things that bring this tech to life?
Oh, absolutely. Render Network has actually been used in production for major TV shows, things like Westworld, The Peripheral. It powered the 4K restoration of Star Trek. The motion picture, a huge project needing immense graphical work.
No way, the Star Trek restoration.
Yep. And in music, it's been used for cutting-edge concert visuals for artists like Zedd, DJ Mustard, even those incredible immersive 360 concert experiences like Anima's show at the Las Vegas Sphere. So this isn't just theory, you know? It's literally being used in Hollywood in major entertainment productions. It's almost kind of ironic, isn't it? A decentralized network enabling some of the biggest, most centralized productions we see really shows the raw power it unlocks.
It really does highlight the capacity and flexibility.
Yeah.
Okay, let's dig a bit deeper. Under the hood, mechanisms that make render efficient and robust. First up, multi-tier pricing. How does that help creators?
All right, multi-tier pricing, MTP, it's all about flexibility. Creators can pick from different tiers based on what they need: speed, cost, security. Tier 1 is trusted. Most expensive, uses verified nodes, gets high priority. Good for sensitive or urgent jobs. Tier 2 is priority. Still high performance, but with a pricing discount compared to Tier 1. Tier 3 is economy. Slowest, maybe uses less advanced hardware, but it's the most cost-effective. These tiers let creators basically optimize their jobs. They can balance their budget against how fast they need it and how secure it needs to be.
So you can dial in those trade-offs: speed, cost, certainty of a verified node. Makes sense.
Yeah.
And with a distributed network like this, reputation must be crucial. How does reputation scoring work to build trust and keep quality high?
Reputation scoring is absolutely vital for both sides, creators and node operators. It builds trust in this decentralized space. Node operators build up their score by completing jobs accurately and on time. This score then directly influences the jobs they get offered, the types of jobs they can even take on. Creators also build reputation by, successfully using the network, paying on time. A good reputation might give them access to more GPUs concurrently for really big projects. The whole system incentivizes good behavior, pushes out bad actors, and helps ensure consistent work quality across the whole network.
Okay, and the ORBX file format. That sounds pretty key to how jobs get distributed. For listeners maybe not deep in 3D stuff, can you explain ORBX quickly? Why is it so important for sending these complex jobs across the network?
Sure thing. The ORBX file format is basically an open, robust container. It supports, I think, over 20 leading industry tools for creating digital content. Think of it like a universal language, or maybe a standardized package for 3D scene data. It's critical because it bundles up all the scene info, the geometry, textures, lighting, camera angles into one self-contained file.
Got it.
This lets the job be processed in parallel across different node operators' machines, even if they don't have the exact same software installed locally. Makes it much more flexible. Plus, it provides this deep chain of authorship and traceability through hashing. That's super important for proving ownership, for licensing in the digital art and AI world.
So it's like a universal instruction manual, ensuring everyone's on the same page, hardware differences aside. Okay, finally, the tokenomics. How does Render Network try to keep a sustainable economy going for everyone involved with this burn and mint equilibrium model?
Right, the burn and mint equilibrium, or BME. It's designed to create a sustainable, multi-sided economy. So services get priced in regular money, like US dollars. Creators can pay either in fiat or in RNDR tokens. Now, here's the clever bit. Once a job is approved, 95% of the fiat value paid, whether it was paid in fiat or RNDR, is used to programmatically buy RNDR from liquidity pools, and then that RNDR is burned.
Burned, meaning removed from circulation.
Exactly. Removed permanently. This reduces the total supply of RNDR, creating deflationary pressure, which can support the token's value. But then, separately, new RNDR tokens are minted. These newly created tokens are distributed as rewards. Rewards go to node operators for providing their GPU power and being available. Rewards also go to creators for actually using the network. And some go to liquidity providers who help make the RNDR market work smoothly.
Okay, that's quite a few moving parts in the burn and mint equilibrium. Let me see if I got the core idea. You burn tokens based on usage to create scarcity, but you also mint new ones to reward participation, aiming for the self-sustaining loop that keeps the network healthy.
That's exactly it. You nailed it. It's all about balancing supply and demand, creating this flywheel effect that incentivizes everyone involved: the compute providers, the compute users, and the people supporting the token's liquidity.
It's a complex system, clearly designed for long-term health. And I gather there was a big technical shift to support this model.
Yes, That's right. The render community actually voted to migrate the implementation of this BME model from Ethereum over to Solana. That reflects a move towards a blockchain platform seen as potentially more efficient and scalable for these kinds of high-volume operations.
Interesting. Okay, finally, let's touch on the RNDR token outlook. Where are things standing, say, right now, around September 2025?
Well, as of September 15th, 2025, based on the sources we looked at, the RNDR token is trading around the $3.77 mark. Looking ahead, some long-term predictions cited in our sources are, well, quite bullish. Potential ROI mentioned of maybe 44.26% by December 2025, possibly over 400% by 2030. There was even a highest estimated price mentioned way out in 2050 of $48.06. However, it's really important to stress the short-term technical indicators mentioned currently suggest a more bearish sentiment. And as always, this is just information from the sources we reviewed. It is absolutely not financial advice. Investing in crypto is speculative, carries significant risks. Do your own research.
Absolutely crucial reminder. Okay, so wrapping this up, what does all this mean for AI's future and the promise of DAI?
What's really remarkable, I think, is the timing. DAI's emergence. These decentralized solutions are being built right now simultaneously with the revolutionary AI tech itself. That really showcases how fast technology is advancing, and maybe our capacity as humans to develop ways to democratize powerful tools as they're being created. It's almost like we're trying proactively to avoid the centralization problems we've seen with other big tech shifts in the past.
It does feel a bit like learning from history in real time, doesn't it?
Precisely. Blockchain tech, these distributed networks, they offer a really promising path, a way to potentially mitigate the risks of centralized AI control, broaden access to these incredible technologies. It's about ensuring this massive shift in human capability isn't just confined to a select few, but maybe opens up to a global collective of innovators.
So, as AI continues to reshape our world at this incredible pace, it really leaves us with a provocative thought, doesn't it?
Right.
What responsibility do we actually have to make sure its development stays open, transparent, accessible to everyone, rather than concentrated in just a few hands? And how might these models, these networks we've talked about today, evolve to shape a truly equitable digital future for all of us?
A profound question indeed, and one that decentralized AI is fundamentally trying to answer by changing the very foundation AI is built on.
Thank you for joining us on this deep dive. We hope this exploration into decentralizing AI's foundation has given you plenty to think about. We'll see you next time.